Okay, so in this question here, graph transformation, right? We've got to shift the graph, and they're asking us to apply this sort of transformation here, right, to f of x. We've got to do f of x minus 3. And the thing to remember with transformations, if it's in the bracket, if the transformation is in the bracket, as it is here, the shift applies to the x-axis, okay? So, in other words, you're going to shift it across. It's going to apply to the x values, if you like, because it is in that bracket, isn't it? And it's going to affect what happens to x first before the function applies to it. So we're going to be shifting across. And the other thing to remember, okay, when it's in the bracket, you always do the opposite, right? So I know it says minus 3, but actually we're going to do plus 3. So we're going to shift it to the right by 3. Okay, that's what that means. So you've always got to do opposite. You've got to think opposite. You can't think as though it's negative, so you're going backwards. No, you do the opposite, plus 3. So we shift it to the right. Okay, and what happens then? You shift the coordinates. So minus 1, 0. If we shift that to the right, minus 1, add 3 onto that, you get 2. So it's going to cross around there. And it's important you write down that coordinate. Okay, 2, 0. 5, 0, shift 3, it'll end up being 8, 0. Okay. And then your maximum point here, it says the highest or lowest point. Well, it's going to be a highest point, your maximum. 2 is going to shift to 5, isn't it? Okay. Add 2 until you get 5. The 7 stays the same. The y value is not affected, yeah? Because remember, it only affects the x in whatever's in the bracket. Because it's in the brackets, and you can affect the x values. And the y value stays the same. So you draw your graph, right? Just a sketch. It doesn't have to be perfect, right? But you need to draw a curve, and you go through your points that you've marked. And the key thing is that you've actually labelled the coordinates exactly as it's mentioned there in the question. So in part B, it says use your neighbour axes below. Sketch the graph of y equals cos x plus 1 for values between 0 and 360. Now what you need to do to start with is put a scale on here, right? And when you scale, you need to go up in 90s. Okay, so 0 to 360 would make sense, wouldn't it? Because if you go up in 90s, you have 90, 180, 270, 360. Now, that means there's 4 lots of 90, right, in here. So we need to try and split this scale up. So we've got 4 lots of 90. Now, it's up to you how you do that. You could maybe just go to 8 centimeters here, okay, and then every 2 represents 90. Okay, so you could do that. You write in then 90 degrees, 180 degrees, 270 degrees, going up in 90s, 360 degrees, and of course you've got 0 there. Okay, and then what you need to remember is what cos of 0 is. Okay, if you remember what cos of 0 is, then the rest of the curve will sort of flow. Now, cos of 0 is 1, right? Cos of 0 is 1. And so as such then, it wouldn't necessarily start here, wouldn't it? It would start up here if we were just asked to draw y equals cos x. Now we're not, I mean, we're asked to draw y equals cos x plus 1, so we've got a bit more work to do. But if we were asked to draw y equals cos x, if we were just asked to draw that, you'd start at 1 and then you'd go down there and you've got your wave then, like that, right? And it goes through these key points, okay? We were asked to draw cos x plus 1, so what that means is going to shift up by 1. Now what I like to do here is just to draw a quick sketch of what cos x would look like. Okay, underneath, there's plenty of room underneath. Let's take a bit more time. Again, right, I'll measure these out here, just so I've got an accurate picture. 2 centimeters. 90, 180, 270, 360. Now, cos x, right, the maximum it can be is 1, and the minimum it can be is minus 1. Okay? Goes between 1 and minus 1, just like sin x. So, cos of 0, remember, is 1, so it goes through there, and then the wave just flows down, right? So it goes through then cos 90, and keeps going, so you've got a trough then at 180, and then it goes up, so it goes through cos 270 at 0, and then it goes back up then to a maximum of 1, right? Now, if we got to draw cos x plus 1, what happens is this whole thing gets shifted up by 1. So our minimum point will actually go up, and it will be 0 here, okay? This here at 0 will be up at 1, and then 1 then, if you're adding 1 to it, will be up 2. So actually, this negative region, there won't be any of the graph there. It will all be shifted up 1. So on the scale up here, I need to be slightly careful. Like, I can't write 1 here. I'm going to have to write 2 up here, right? Okay, so maybe just measure this out properly as best as I can. So put 1 there, maybe let's go halfway there, roughly about there. So 1 here and 2 there. Okay, that's what we're going to need. So cos x is 1, so cos x plus 1 will be 2. So we add 1 onto it. Cos 90 is 0, so cos 90 plus 1 will be 1. It shifts up 1. Cos 180 is minus 1, so then add 1 to it, it will be 0. Cos 270 is 0, add 1 to it, you end up here. And then cos 360 is 1, add 1 to it, we end up here. Okay, so it's the graph then shifted. It looks like a bit like a V, so be careful, right? You know, it has got to be like a wave, right? Okay, so don't draw a V. It's got to look like that, right? So it looks sort of wavy. And we're done.